Circular motion, an object has two criteria that it needs to keep constant. What are those two values? J. Constant radius is one of them. If it wasn't moving at a constant radius, it wouldn't be in a circular path. Now, what's the other one? The mass of the object will always stay the same. Anybody else? Jay? What? The speed. The speed of the object, just the magnitude of the velocity stays a constant. We know the velocity changes because the direction changes. But the speed, how fast the object is going, 5 meters per second, 10 meters per second, stays the same throughout the circular path. So today we're going to cover vector applications with the question, what applies the centripetal force? It's going to go off of what we did yesterday in the circular motion lab with the stopper. So an object in circular motion, there must be a force that acts towards the center of the circle. This force is in the same direction as what other vector? The acceleration? Who said it over at that table? I heard acceleration. The acceleration points towards the center of the circle. Force and acceleration always point in the same direction. The velocity, what direction does the velocity point? Perpendicular to the circle. It's tangent to the circle. It only meets it at one point. Fc, or the centripetal force, is not a new force. It's just another name for forces we already know. That name, centripetal, means towards the center, or center seeking. Right? Fc can be any of the forces we already know. We've covered force of gravity, we've covered force of friction, we've covered normal force, we've covered tension. Are there any other forces that we know, that we've worked with? I don't think so. I can't think of any other ones. We just covered those four in different situations. The force, or the force component that points towards the center, provides the centripetal force. All right? That force being the Fc in the equation, Fc is equal to mv squared over r. There's 7 situations. We're probably going to cover 5 of them. There's problem-solving strategies that you use to get the maximum number of points on the AP test for questions involving circular motion. Step 1, draw a free body diagram. Label all the forces, all the true forces that are acting on the object. We know centrifugal is one of those pseudo forces. There's no such thing as a centrifugal force, or a force pushing away from the center of the circle. It's only the force pulling towards the center. Determine which force provides the centripetal force from your free body diagram. And the last step, relate this force to the equation Fc is equal to mv squared over r. So in each of these following situations, I'm going to put on the board a free body diagram. I'm going to label what Fc is equal to, and I'm going to write the equation that you can use when solving problems. Number 1, a box connected on a string. Right? Draw a free body diagram. Put the person in the middle. Have a string connected to an object on the circle. Okay? What force, who can tell me the force that's keeping this object in the circular path? What? What force were we studying yesterday that kept the object in the circular path? What is connecting this object to the person?
E is the tension.
The tension. The string is connecting the object, the mass, to the person. We call the forces that exist in strings and cables and wires the tension force. So tension is acting towards the center of the circle. Another way to think about it, let's take away the tension, take away the string. What is the motion of this object? Straight line. If you take away the force and the object moves in a straight line, there is your centripetal force. We take away the force of tension, take away the string, the object moves in a straight line, we have found our centripetal force. All right? So Ft acts towards the center of the circle. Right? So step 1, we drew the free body diagram. Step 2, we found our centripetal force. Ft is equal to Fc. All right? The tension in the string is causing the centripetal force. Jake, do you have a question? No? Okay. Fc is equal to mv squared over r. Now we're going to find the equation that will help us solve these problems. Fc is equal to mv squared over r. But now we know that Fc is just the force of tension in the string. Let's substitute force of tension. And we get force of tension is equal to mv